So let's pick up where we left off. Set the IP addresses for all the connections from R1 to R2 and R1 to R3. So that doesn't include our Ether channel because that's going to be next. Note, if your OS does not allow /31 subnets, use /30 subnets. I am positive that VyOS allows for 31 subnets. If you're kind of a newer CCNA student or whatever and you don't know what I'm talking about here, Packet Tracer does not allow you to use any subnet that does not include a network and broadcast address, which is why you have to use /30s for point-to-points, because that gives you one network address, one broadcast address, and two host addresses, which you use for, either side of this connection. That's not necessary, except for certain protocols that rely on broadcasts, like RIP, and some really, really old equipment. So as a matter of course, I use /31s because it conserves more addresses and it also protects you from directed broadcast attacks to a certain extent. So anyway, let's just set this up according to our chart here. So in iOS, as you know, there are shells. So you would say interface E00 or what have you, and that brings you into an interface configuration shell. VyOS does not have that. Everything is done in the configuration shell or in the user shell. So in the configuration shell, this can lead to some really long command lines because you have to type every configuration command with all your parameters. The only good thing about this is that there are times, especially if you're new, where sometimes in iOS you'll forget which shell you're in or which you have to be in to use a certain command or command family, and that doesn't happen here. Anyway, this is how you do it. Set interface eth. Which one are we setting up here? Ethernet 1. Ethernet 1 address 10.0.0.1/31. And I think that's correct. Yep. And now we can just change this to a 2. And that is number 3. Commit. All right, now I'm going to jump down into router 2, which is here, and we're going to set up that interface, which I think, is that Ethernet 1? I believe it is. Yep. Now let's just make sure that this worked. Well, that's us. Duh. And that's router 1. Okay. Now let's jump over to router 3. And we have connectivity there. Let's see, now what? Create a layer 3 LACP Ether channel. Oh, that's these two. Yeah, these have to be connected. In VyOS, this is called bonded channel, and I'll just show you how to set it up. So this is router 2. This is router 3. I think I remember how to do this. Set interface Ethernet ether. Let's see, Ethernet 2, and here we can assign to a bond group. I think we can do that without actually creating the bond group first. Let's try it. Bond group. bond 0. Let's see if this creates our bond group. Okay, we have to create the bond group first. Let's call this bond 0. And do we have to build anything right now? Yeah, apparently we have to address it. So we have to do this a little bit backwards. So let's see. So our ether channel on this side is going to be 10004. Okay, and now I think we can set our physical interfaces into the bonded group. Let's see. What? There's some strange error messages sometimes. So there you see I got the warning because I didn't save it. Configuration changes have not been saved. That's fine. I think there is a command that shows us bonding group information. Actually, if I just do a show int again, I mean, it says that interface is up. You know what? I'm going to just put the other interface into there and see if the bonding group accepts it. And that took the command without any complaint. So it could be that the configuration command was already present in my config file, but it threw the error anyway because the bond group didn't exist, so I was doing it out of order. All right, let's do this over here. Okay, in this case I did an order, so it didn't spit an error at me. Let's save it. Oh, we'll commit it first. Then we'll save it. And I'll just try and ping across this interface. Yep. Okay, one thing that I realized just now that I forgot, because the instructions specify LACP, and I kind of skipped that because there are a lot of bonding options here, but one of them that's default is that because the VyOS is an open source, is that LACP is kind of default. Let me just see if I can find this. Okay, there should be a mode command. And you see here 802.3AD, that up here, that is the standard that determines LACP link aggregation, and that, as you can see, is the default. There's a lot of other interesting options here for traffic handling and balancing. We're not going to use any of them, but I think let's try this here. Okay, here you can see there's a slow protocol LACP because now the channels are bonded, so they're just reminding each other that they're alive periodically. That's what's going on here. So yeah, we were confirming that there is LACP traffic on this channel. Let's just minimize that for a second and see what's left. Okay, now I have to create subinterfaces from router 2 down to the switch, and I believe this is Ethernet 0. Yep. Let's see. Okay. This is actually fairly simple too. Let's just take a look here. And we're not going to be able to test it until we get these hosts up. Okay, so int eth0, and this is how you do it. Normally you would create subinterfaces on a Cisco router. It's a little bit different here. Here they call it VIF, VIF, Virtual Local Area Network. I think that stands for Virtual Interface or something. But anyway, this is how you assign them to VLANs, which you should know routers don't typically directly deal with. So we're going to put this in a VIF of 10 because our first VLAN that we have to deal with is 10. And we're going to address it. Yep. And now we're going to go back up here and just change this to VIF 20. Change this to 20. Save it. Show interfaces here. And here you'll see Ethernet 0. It's got no address on it. That's correct. Ethernet 0.10, that's our first subinterface, is correctly addressed, and so is Ethernet 0.20. So we're already through this section here. So next time we're going to create an OSPF network between these three routers, and that will allow us to see whether or not our default router worked. See you next time.